integer in part A and int value in part B. Okay? Does that clear things up? Tamim? Does that clear things up? Okay, great. The reason that's even there at all is because if we remember lists or array lists, right, exactly, lists and array lists can only contain objects. Well, ints are primitive data types. So when you try to put an int into a list, there is something called the process of auto boxing, right? So you can think of it as this primitive data type is put into a box, and the box is sort of like represents like an object, okay? And then when you go to retrieve the integer object from the list, it unboxes it automatically, returning a primitive data type, okay? So using the version of Java that we now have, that everybody has, there's no need to do that. So it's really just like letting you know, hey, this is what's happening behind the scenes, but it's done for everyone automatically now, and it wasn't necessary to include in your solution, okay? As I will illustrate in my code, that works perfectly fine, and I didn't use int value, and I didn't use new integer either, okay? All right, so let's begin. Hopefully, this question seemed somewhat familiar for two reasons. One, there are some really striking similarities to the 2007 FRQ number 1 self-divisor. I think it was 2007 number 1 self, and in any case, it's very, very similar to the self-divisor question, at least part A is. And then, of course, we did this problem at some point during the year. So earlier in the year, when we covered array lists, we most certainly did this question. So hopefully it seemed familiar to you. I think it was pretty straightforward. I also think it was easier than the question we did yesterday. So let's go ahead and take a look. All right. So it says, this question involves identifying and processing the digits of a non-negative integer. The declaration of digits of the digits class is shown below. You will write the constructor and one method for the digits class. Now, even though we did this question a while ago, I still felt like it was important to do because we haven't talked about the constructor explicitly as much lately, but it's certainly possible that on tomorrow's exam, you could be asked to write the implementation for a constructor. All right. In some ways, and depending on the textbook, it'll refer to the constructor as a special type of method. Okay. And then there are others that will say that the constructor is not a method at all. So it really just depends on who you're reading. But it's definitely possible that tomorrow, one of the sub-questions you get asks you to write the implementation for a constructor. Now, of course, we've typically seen that only when you were asked to write a full class. And look, I'm going to say, like, all bets are off. You could be asked to write a full class. I really highly doubt that, because we were told that the two questions, one of them is going to be methods and control structures, and the other will be an array or an array list question. All right. Now, I suppose it's possible that they combine those two things, but we should be in good shape with that because we've been writing full classes throughout this whole review process, okay? All right. So back to the problem. We have public class digits, and we're told the list of digits from the number used to construct this object. The digits appear in the list in the same order in which they appear in the original number. That's important as well. So we have one private instance variable, which is digit list. So that is the variable that refers to the array list of integer objects, okay? The constructor constructs a digits object that represents num. Okay, num is greater than or equal to 0. So part A, we're going to be writing the implementation for the constructor here. And then we'll come back to the as strictly as increasing. Okay, so let's take a look at some of these examples here. So D1, digits D1 is assigned to new digits 15704. So I'm going to hop over to my main method real quick. And we can see digits D1 is assigned to new digits 15704. Did the same with D2, okay, to match up that second example. And let's just read what they have to say. Write the constructor for the digits class. The constructor initializes and fills the digit list. Okay, so this line right here, very critical. If you get a question tomorrow that has to do with an array list, in all likelihood, the list or array list will have been declared, but it will not have been initialized, nor will it have been filled. Okay, lists are a three-step process: the declaration, the initialization, which creates the size of it, and then the filling it, the process of filling it. Okay, so let's actually go to our solution real quick, and we can take a look at part of this. All right, so here's the declaration that was given to us. Here's our constructor. All right, we're told we have to initialize it. So line 16 represents the initialization of digit list. So digit list equals, or is assigned to, new array list, integer, and then the open parentheses, close parentheses, colon. This line right here, line 16, initializes the list. So now we have a blank list. Okay, there's nothing in it. There's absolutely nothing in it, but it's been initialized. It's been declared initialized. Now the subsequent lines of code will fill the list. Okay, I suspect that many people will forget to write what you see in line 16. Now that'll probably only yield a half a point to a point deduction, but if you're somebody who is quick enough to use the IDE and test your code, if you miss that line there and you're dealing with an array list, then you're going to get some type of error message. Okay, you're going to get some type of error message. Okay, so back to the instructions. So it seems like all we're doing is we're taking each number and we're putting it into, or each digit rather, and we're putting it into the list at a specific index, okay? And the digits should appear in the same order as they appear in the number. Okay, so I need to, and this is why I said it's very similar to the self-divisor question. So I need to isolate each individual digit, then I need to update the number so that it has one fewer digit than in the previous iteration, meaning the first time through the loop, we're going to be looping through the number. We want to isolate the 4, right? Then we want to update the number from 15704 to 1570. That way we can isolate the 0 and then continue that process. So there is one thing that we also need to consider, which is that a digit object can just be 0, okay? And I'll address why we need this conditional here rather than simply saying num is greater than or equal to 0. So we have if num equals 0, then you're going to add that num to the digit list, okay? Now, while num is greater than 0, we are going to declare a variable called digit, which will be of type integer object, not int not int, primitive data type, and that will be assigned to num mod 10. So this is why, again, I said it's very similar to the self-divisor question. We know that in order to isolate the far right most digit, we have to use modulus 10. We can then take that result and store it in a variable. We want to add that digit to the list. Now, can somebody explain, you can just type it into the chat, why is it absolutely critical to add this digit at position 0? What would happen if instead I just said add digit? How might that change our resulting digit list? Yep. Anybody else? The order of them is okay. How would they be different specifically? It will put the digits back. Yes, Kalindu. It will put the digits backwards. Exactly. Right, says Shpreet. Yep. Correct. Okay. So that's why we want to add at position 0. So remember, we're adding, we're not setting. The set method would copy over it essentially, right? It would reassign what's at that index to that new value, but we're adding it at that position. So let's say you have a digit at position 0, but now you're saying add this other digit at position 0. All that happens is whatever's at position 0 gets shifted one index to the right, okay? So what's at that specific index doesn't get copied over, it just moves to the right. If you were using the set method, however, whatever object would be held in that position would be copied over, so to speak, okay? That data would be lost and no longer there, and that new element would be in its place. But again, we're not setting, we're adding. We need to update the number so that it has one fewer digit, and more specifically, the far rightmost digit is no longer there. So num is assigned to num divided by 10. By doing this, we're performing integer division. So the far rightmost digit will be truncated, okay, will be lost. And we simply continue this process so long as num is greater than 0. Now, let's assume for a second that I got rid of this conditional on lines 17 through 20, and I made this greater than or equal to instead. What would happen if I got rid of this conditional and made this just greater than or equal to? Yes, Melanie, we would get an infinite loop, okay? Because as you update the num the last time through, right, once you get to a single digit, any single digit divided by 10 in integer division will give you 0. So if it's greater than or equal to, 0 will always be greater than or equal to 0, and you'll continue to perform that integer division, getting 0, and it'll be endless. It'll be an infinite loop, precisely. Okay, so that's it for part A. I'm going to go ahead and run my solution. Here's part A. In the main, we have a digits object, 15704 and 15704. Oh, I should have pointed out that I added to my class, I added a print digits method using a for each loop. So for each integer object, or for each integer element in the digits list, simply print out element with a space, and I just added an extra blank space after we were done using the method. That's all. Okay. That way, this is 0. Otherwise, this 0 would print on the same line here. So that's how I was able to print the individual digits. I got each digit from the list, printed it out, and there we have it, 15704. And then, of course, for digits with num0 as a parameter, prints out, this is a list that you're seeing. I know it doesn't seem any different than if we were just printing numbers, but these are lists right here, okay, with integer objects at each position. Well, actually, no, because I use the print digits method, they're actually not lists. They're the specific values at each respective position from the list that we extracted them from. Okay, so by invoking the print digits method on these objects, we were able to print each digit from the list. Of course, without the print digits, if I just said system.out print ln d1, we would get the object reference. And we can see that right here, digits at 76ED5528. Okay, so we got the reference to that object. Okay. You use negative indexes for the array list. How did you do that, Kalindu? Maybe you want to post your code, copy it, paste it in, so we can take a look. Kalindu, are you going to share your code with us? Oh, there it is. Sorry. Okay. I think you can only use negative indices in Python, but we'll take a look here. Okie dokie. 1 second. Problem there. Okay. Give me a second. I'm just going to paste this in here so I don't lose it. Okay, 1 sec. All right, so this is Kalindu's. All right, index -1, temp is num. All right, so this is fine, transparent, as long as temp is greater than 0. Digits dot add at index temp mod 10 index minus minus. So you're just making them more negative. I don't think this is going to work. Yeah, you get range check. Yeah, so you can't use the negative. You're getting the index out of bounds. I know that works in Python, Kalindu, or you can use the negative indices in Python, but we're not able to do that in Java, okay? Or at least not in this way. Tamim, are you asking me a question? Oh, okay. All right, so let's take a look at part B, which asks us to write the implementation or write a implementation for the is strictly increasing method. We're given several examples of this method in action. So we can see that if there's only one digit, that the is strictly method should return true no matter what. And then the only other instance in which it'll return true is if all of the digits are in ascending order. So from the smallest number to the largest number. Another way that we can say this is that the previous number is less than the current number, okay? So for example, 3, if 3 is the current number, then since 3 is greater than 1, that checks out. 5 is greater than 3, that checks out. 6 is greater than 5, that checks out, so it returns true. Now notice the third example, 1336, returns false. So even though 3 is greater than 1, 3 is not greater than 3, and thus it will return false. So another key component to writing this implementation is that as soon as you get 2 digits that do not satisfy the condition, you should automatically return. You should stop what you're doing straight away and return false. Okay. I can't recall the question off the top of my head, but we've seen something like this in the past where you are going to be performing some type of iterative process, meaning you're going to be using a loop. And if you loop through the entire, whether it be a number or a data structure, and all of the pieces of data have to satisfy the condition in order for it to return true, and only one instance will make it false, then if you continue to loop through and you don't have your return statement until the very end, and you're using some type of variable where you're reassigning it to true or false, you could inadvertently, right, return true if the way you set it up has the code reassigning some variable to true after the process is complete. Then what might happen is it could be false, 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 and then if the last 2 digits satisfy the condition, then it'll change the value of that variable to true and return true incorrectly. So you want to return false in the body of your loop, in the body of a condition, as soon as that condition is no longer true, okay? So let's go ahead and take a look at a possible implementation for this. Mine is slightly different than the solution given, and we'll go back to that one as soon as we're done looking at this. So I decided to use a while loop. They used a for loop. If you're going to use a while loop, then it's most likely that you're going to need some index variable that needs to be declared outside, or sorry, rather prior to the while loop. Because I know that I'm going to be comparing adjacent pieces of data, I decided to make my index 1 and not 0. This allowed me to say digitlist.get index -1 to represent the previous digit. So the first time through the loop, this would be 1 - 1, which is 0. So it would get the element at position 0, and then compare it to digitlist.get index. Index is 1, so it's comparing it to the object at position 1. If the digit at position 0 is less than the digit at position 1, then you're going to continue to iterate through. Else, if the previous one is not less than the current one, you could say, then you will return false, okay? And remember we said there was that one question where we used the keyword return and nothing else, and it acted as a break from the method. That's what, if you have return false within a conditional that's in the loop of a method, then you're going to stop what you're doing and you're going to return false. You're not going to continue iterating through the loop, okay? And then notice, if we make it through the entire data structure without having returned false, so we've made it through the entire loop without ever having come to this part here, then we will return true.
I can't see your screen. Sorry.
Oh, you can't see my screen. Uh-oh. Got it, thanks. Okay, back to it. All right, so you heard me say everything, now you can see it. All right, so we have index is 1, as long as index is less than the digit list dot size, because we want to go through the entire data structure, the entire list. Digit list dot get index minus 1 would represent the previous number, the previous digit, and as long as that is less than the current digit, digit list dot get index, then you will continue to iterate through the data structure. If you make it through the entire data structure without this ever being false, then that means you will never have executed lines 48 through 51, and thus you will have exited the loop without having ever returned this, and thus you will return true. Okay? So if this is a true statement for every comparison of two adjacent digits in the list, then when you're done iterating through the loop, you will return true. Okay? So again, I think this is pretty straightforward for me. The solution provided by the AP College Board is even more compact than what I wrote, and we can take a look at that in just a moment. I'll give everybody a second to look this over. And as you can see here with my part B, 15704 is not strictly increasing and should return false, and it returned false. 7 is strictly increasing and should return true, it returned true. 1356 is strictly increasing and should return true, and it returned true. 1336 is not strictly increasing and should return false, and it returned false. Okay? Yes, you can use a for loop. Let's take a look at the solution here. Jay, go ahead and post your code. So this was the solution provided by the College Board. They used a for loop. Notice they said digit list dot size minus 1, so that you didn't get an out of bounds exception error. The reason you had to say digit list dot size minus 1 was because we are referencing an index plus 1 here, I plus 1. So because we're dealing with, whenever you're dealing with referencing adjacent pieces of information in a data structure, you should immediately think, okay, I have to make sure I don't get an out of bounds error. That should always be back in the back of your mind, okay? Whenever you're comparing two adjacent pieces of information within an array or an array list, you have to think about how you're going to make sure you don't get that out of bounds error. Because if you're comparing two adjacent pieces of information within a list or an array, right, you have to be either referencing the previous one and the current one, or the current one and the next one, okay? So they said digit list dot size minus 1, digit list dot get I, this is not needed, this in value thing here, and that's all explained in this note. Okay, so this is not needed. If digit list dot get I is greater than or equal to, so this is like the inverse of what I had. Digit list dot get I is greater than or equal to the next one, then you return false. Otherwise, return true. Okay? Yeah, I just think for older versions of Java, Tanmim, you have to use that. That's all. I think in the older versions of Java, it doesn't do the auto boxing and auto unboxing thing. All right, let's take a look at Jay's code. Did I use a toString? No, I had no toString. Remember, I wrote a method called print digits that would print all the digits out. All this stuff that you see here is from my main method. I just said system.out_print. No, I didn't have a toString method. I just invoked the isStrictlyIncreasing method on the object and concatenated that with a sentence describing what the method should return. That's all. Let's take a look at Jay's work real quick, okay? All right, I'm going to change this to a lower case. Well, I'll keep that cap. We'll just make it a capital I so that it's, remember, you can't have two methods with the exact same signature. The program won't know which method to call at runtime. All right, so let's take a look at Jay's work. See if it works. Okay. All right. Just going to go to the main method. We'll say system.out_println d2. Oh, we'll go with d3 dot is. So that's your method there, Jay, with the capital I. System.out_println a d4 dot and d5. So let's see what we get. So we got true, true, false. True, true, false. Okay, seems to be working there, Jay. I'll just throw it in for E2. Zero. That's one that I didn't, hang on, what was it? Was there a precondition for part B? The method returns true if the elements of the digit list appear in strictly increasing order, otherwise it returns false. Okay, let's take a look. Did they give us a precondition? True if the digits in this digits object are strictly in increasing order, false otherwise. Huh. I'm just wondering about the zero. Let me see what happens with mine. Okay, Jay, notice that my method returned true for 0 and yours returned false. Okay, so it seems to be working except for 0, Jay. So your method is mostly correct, but it's not 100% correct. What are you saying, Tamim? 3 and 8? Jay, we'll dissect it in just a second. What does that mean, Tamim? 3, 8? Oh, all right, no problem. Let's figure out, Jay, why yours is just a little bit off. And maybe we can all look at it together, and perhaps you can spot the just slight error along with me. So I'd like to indent this. All right, so you're looping through the whole list one by one. If the digit list.getX is greater than low, then low is assigned to digit list.getX. Wait, so if digit list.get, so at position 0 is, no, Jay, you know what? I think there's more wrong with it than just, I think it happens to work for these other examples, but hang on a sec. Maybe not. If digit list.getX, I see what you're saying, because if it was a single digit like 1, 2, 3, that's why it's not working for low, because when it's just 0, 0 is not greater than 0, right? So what happened was it returned false. That's why we were getting false for the 0, but it should return true. Digit list.getX is greater than low. Low is, now I need to see if you're comparing adjacent numbers here. Digit list, so low is assigned to digit list.getX. Okay, I guess you're returning false otherwise, so it should be comparing the adjacent. So then when you get to 1, right? Okay, so low. Depending on how you can fix this maybe. He said digit list dot. What if we did this, Jay? Instead of setting this to a default of 0, right? You could say digit list dot get at position 0. So it's the first element in the list is the low, and then you go from there. Okay, and then instead of starting at position 0, you would start at position 1. And I think so this was false right here. See how it says false? That was for the 0. It should work. Oh, maybe not. Oh, yeah. It should work. Maybe not because of the single. Let's just try it. What happened here? Why is it? Okay. Supposed to return false, Matthew. The return type of the method is Boolean. So you would lose a point if you return 0 or 1. The method must return true or false, as stated right here. Value returned, true, true, false, false, false. We can see right here, public Boolean. So it should return, it says right here, returns true if the digits in the digits object are strictly increasing order, false otherwise. So 0 is true, 7 is true. Okay, I think this works now. Let's do the 157. Let's go back. Let's just do it for digits 1 as well. False, false. Oh, that's from, okay. There we go. False, true, true, false, false. False, true, true, false. Yep. Or false, true, 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 false. Yep. Okay, we're good now, Jay. So if you change this, right, instead of having low assigned to 0, if you assign it to whatever the first element in the list is, and then compare each subsequent, well, you compare the next element to that, and then it shifts, then I believe this is, yeah, this will work now with that slight edit. So I think you would have lost a point there, Jay. This was worth probably 5 points. You would have lost 1 point. No big deal. Isn't 0 supposed to return true for this FRQ? Yes, it is, Matthew. Yes, it should return true. Jay, you want to know if that works? Works instead of what? So you gave me that conditional. So if digit list or digit list dot get 0 equals 0, and then get rid of what am I, so on, and then you're keeping low 0, and then you're keeping this 0. Is that correct? So this is what you want me to test? So or digit list dot get 0 equals 0, then the low gets reassigned to digit list dot get x, which would be 0, and then you, oh, and then the list is finished. Yeah, I think that would work. That should work. Yep. Yep, all good. That works too. That works too, Jay. Okay. No problem. All right. That's it for 2017, number 1, unless there are any other questions. Any other questions about 2017, number 1? Or just any questions about really anything in general? Yeah, we can do a Google Meet tomorrow, Jess Winder. No problem.